Well, thank you and welcome back to East Academia. So my name is Brian Modena, and today we are going to talk about, we are going to continue the series in calculus, and we are going to talk about evaluating limits using factorization method. So the topic here is limits by factorization. So basically, we've defined what a function is, we've defined what a limit is, and we know what exactly limit is. On the previous video, we talked about factorization. So today, we are going to evaluate a situation whereby direct substitution is not going to apply, and therefore we are supposed to use factorization method so that we can get the value of our limit. So the question that I'm going to do some example, and then I shall give you some example for you to do, and then as usual we shall see if you are able to learn, and if you are not, we shall evaluate the solutions together, and then we see what we can do. So the first question that I'll do is evaluate the limit. So you're told to evaluate. So the limit is limit as x approaches to. So limit as x approaches to of x squared minus 4 over x minus 2. So that is the question. So when you're given such a question, how to go about the solution is very simple. So first of all, we'll write here solution, and as I said, first we usually test the solution using direct substitution first. So on direct substitution, what answer do we get? We get that on direct substitution, this bracket term now, if we replace the x with 2, you are going to get x squared minus 4, and then on the denominator, we are going to get 2 minus 2, which this will be 4 minus 4 over 2 minus 2. This definitely will give 0 over 0. And we said any number divided by 0 is undefined, isn't it? So you can even confirm with your calculator. Let me just take out a calculator here, so that or I can just take the other one. Let me take the one that normally people have. So when you take like 0 divided by 0, you see that this number is undefined. So that means this is not a solution, isn't it? So when you put on direct substitution and you see that you are getting the solution as undefined, then that means we should go for a different technique. Okay, and the next technique that we discussed was factorization. So factorization. So how do we go about factorization? First, we look at the numerator, isn't it? So the numerator is x squared minus 4. So this is it's an equation in the second order, okay, of order 2, because it has an x squared. So it is the one that we can factorize, and then we see how we can get a term that can cancel with the denominator, isn't it? So then last time we said that x squared, we can factorize x squared minus 4 into 2 terms, which is, so when you solve x squared here, you are going to get x squared is equals to 4, and you're going to get x is either plus or minus 2, isn't it? So when x is plus or minus 2, this means that x squared plus 4 can be written as x plus 2 into brackets x minus 2, isn't it? So then, what that means in essence is that our question here, we can write this question here, again, this question here, we can write it in this form, that it will be limit as x approaches to of x plus 2 x minus 2 over x minus 2, isn't it? And then before we substitute the value of x, we can see that the numerator and the denominator, there's a term that can cancel, isn't it? So we cancel those terms that can cancel out. So which terms are those? We see that this term can cancel with this one, isn't it? So then, under that simplification, we get that our limit can be rewritten as limit as x approaches 2 of x plus 2, which upon substituting the value of 2 in where we have x, we are going to get that this answer will be 4. Okay, so that is the first example. So we can proceed to, let's have another question, another example. But basically that's how factorization is doing. So question 2, you are told to evaluate the limit as x approaches. So you are told to evaluate the limit as x approaches a minute. You are told to evaluate the limit as x approaches 1. As x approaches 1 of x squared plus x minus 2 okay, a minute, just a minute. I'm trying to see something here. It's supposed to be x approaches minus 1, not 1, okay? As x approaches minus 1 of 2x squared, okay? 2x squared minus x. I'll just have to rub some 2x squared, okay, minus x. So this will just do this so that you cannot, so that I don't confuse. That's a bracket. So 2x squared minus x minus 3 over x plus 1. So the first thing you're supposed to do is direct substitution. So solution on direct substitution, we realize that this will be 2 raised into minus 1 squared minus 1, isn't it? Minus 3 over minus 1 plus 1. What does this give us on the numerator? So here we are going to get minus 1 squared is positive 1 times 2. It's going to be 2. 2, and then this minus minus will give us positive, so this will give us 3. 3 minus 3 will give us a 0. And then for the denominator, minus 1 plus 1 is 0, so this is an undefined or indeterminate. So then we employ the second method, which is factorization. So for the previous video, now what you do, we look at which term is a quadratic term. Like when we look, the one that has a high power or the second order power is the numerator. So what you do, we try to factorize the numerator and see what you can get. So we want two numbers. So 2x squared minus x minus 3. We want to factorize this one into two terms. So the two numbers that we want here is the product of those two numbers, which is a times b, should give us the product of minus 3 and this one, which is minus 6. And then the sum a plus b should give us minus 1, isn't it? So what terms are those? So those terms are minus 6 and positive 1. So with minus 6 and positive 1, we can write this. So this is just the factorization. And you can also use a calculator, which might be easier. So it will be minus 2 minus, so here we'll have minus 6x, then we have plus x, it's 5, huh? It's minus 6 and positive 5. I'm sorry about that. No. Just a minute. Okay, so sorry about that. So you are I was just checking on something a little bit. So it's okay, we want the product to be 2 times minus 3, which is minus 6, and then we want the sum to be minus 1, isn't it? So we want the sum to be minus 1. So which two numbers are these that the sum will give us, the product will give us minus 6, and then the sum to be minus 1. So I'll just rub some of this work here. Yeah, so the sum should be minus 1. So these two numbers, when you think of these two numbers, we realize that the two numbers are minus 3 and 2. Such that when you take minus 3 times 2, you are going to get minus 6, and minus 3 plus 2 is you are going to get minus 1, isn't it? Yeah, so that one is okay. So we can then, that means we can rewrite this this equation here this way. So it will be 2x squared, okay, plus 2x, isn't it, minus 3x minus 3. And then we can factor out 2x here, and then we will have this as x plus 1, yes, and then you can factor out minus 3 here, such that you will have x plus 1. So here we'll have 2x minus 3 into brackets x plus 1. So that's what we have, isn't it? So when we have this one, this means that this question here, this question that you're having here, we can write that limit in this form. So that means we can write our limit. So now it will be limit, and then we can have as x approaches minus 1 of 2x minus 3 into x plus 1 over x plus 1. And then this x plus 1 can cancel out to that one. And then now we'll remain with limit. It's equivalent to limit with x minus 1 as x approaches minus 1 into 2x minus 3. So wherever now we have x, we're going to put minus 1, I mean, sorry. So this means that our solution will be 2 into minus 1 minus 3. So this will give us minus 2 minus 3, which now solution will be minus 5. Okay, yes. And then there's a way that maybe you can like the last video showed you how you can use this calculator to get the factors instead of going the long way. So like this one, you just input the coefficient. So you have the coefficient is 2, and then we have here it's minus 1, and then we have 3. So this gives you it's bringing some complex numbers. So we have 2 minus 1 and minus 3. This should be minus 3. Sorry about that, you have to be careful when you're doing this. So you're getting the first x is 3 over 2, and then the other one is minus 1. So this means that the solution that was obtained here initially was in this form, Let me show you how you can go about when you're using a calculator, so that you can avoid wastage of time. So this calculator really saves time. Like I showed you, to input, you just go on, you go to mode, you just go to mode. After mode, go to equation, and then you take that second order equation there, and then you put the coefficients. So the coefficients were 2, minus 1, and minus 3, and it's giving us the answer as 3/2. So x1, so the first x is so x is equals to 3/2, and x is equal to, and the second one is x is equals to minus 1. So what you do to factorize this, first of all, you make sure here you have a complete fraction. You should not have this fraction. So what you do, you just take these two, put it here. So you'll have 2x minus 2x is equals to 3, isn't it? That's what you're going to get here. And then for this one, we have it still remain x is equals to minus 1. And then, because these were the roots, so you can take this x this other side. So you'll have here x plus 1 into brackets. Then you can take this 3 this other side. You're going to have 2x minus 3. So you see, this just takes you back to where we were, which is here. So you can see, like for me, when I use a calculator, I can easily reach here than going through this method, which sometimes maybe I might make mistakes. Okay. And the good thing about the calculator, it will tell you if something is not factorizable. It will tell you, because it's going to give you complex roots. Okay, so complex roots are the ones that have this imaginary portion here. Like, let me just guess some numbers and then you see if you're going to get. Okay, all of these things I'm guessing I can see they're having let me see if I'm going to get complex roots. So I'm still not getting complex roots because I don't know. But I think you've seen previously you had obtained to some complex roots. So that's a shortcut for using a calculator. So if you use a calculator, this is the way to go. But you have to make sure that at this point you do not confuse. Okay, you do not take this one, because assuming if you're not going to multiply and get this one, so let's see how our answer is going to be if you don't multiply. So you're going to have x minus 3/2 into x plus 1, isn't it? So you're going to have limit as x approaches minus 1, and then down here you're going to have that x plus 1, then this will cancel this one. And then what you're going to get here, so the solution here now from this, what you're going to obtain is you're going to obtain that the solution here you're going to get is minus 1 minus 3/2, which this will give you minus 5/2, which now this solution is wrong. Okay, this solution is wrong. Do you know why? Because here, whatever we are using here is multiplication. Okay, multiplication and division. But here, when you are crossing over with a addition, or rather subtraction. You are crossing over with subtraction. So there's this mathematical property of commutative and whatever. So before you cross over, make sure that this denominator here, you multiply it with this side so that you can remain here with a complete fraction. And then now you can subtract. You can take it and subtract, because commutative, when you go to commutative property of addition and subtraction and multiplication, and so all those rules, all of them, I think you've done them. So make sure first you do not cross over. You do not cross over until whatever is in the denominator is multiplied with x. So that's a catch, and that's where many people fail. And I've seen so many students doing that way, and they end up. So a calculator is good, but if you're not, if you are not following rules, if you're not good at following rules, understanding how these things are, then you might end up failing, because like this guy will get a 0 for not following instructions, or because you can see the answer is -5 and this guy is getting -5/2. So then that takes us to another question. And I think this will be the last question, and this question I'm going to give you to do, and then it's the question that you're going to have before we get to the next technique of evaluating limits, which is the Hopital's rule. So okay, so the next question that I'm going to give you as an exercise to do, and then we shall see if you're getting the solution is solve or evaluate the limit. So you are told to evaluate the limit. So the limit is limit as x approaches 1 over x squared plus x minus 2 over x minus 1. So first of all, you can pause the video and then you do, and then you see if the solution that you're getting is just like it's the same as the one that you're having. So I'm going to give you 5 seconds for that. Okay, so now so the solution, so I hope you've solved it, and then now we are here to see the solution. So the solution first, we said on direct substitution, what are we going to get on direct substitution? So wherever there's x, we put 1. So we are going to get 1 squared plus 1 minus 2 over 1 minus 1. So you are going to get on direct substitution, you are getting this is 2 minus 2, which is 0 over 0. So this is undefined or indeterminate. Okay, so then that means we employ the next technique, which is factorization. So when you employ factorization, we look at which term is to be factorized. Is it the upper one or the lower one? So it's the upper one because it's the one that is a second order. Okay, for this question I'll just use a calculator because for the so that we can save time. And then for you, I don't know if you're allowed to use a calculator or not, but for me I'll just use a calculator, and not this one, the one that can have. So I'll just go on, and then I'll go to mod 5, which is a question, and then I'll take that first order. So I'll take the coefficients there. It's 1 and minus 2. So I'm going to get the first one is x is equals to 1, and we have x is equal to, and then we have x is equals to minus 2. So x is equals to 1 or x is equals to minus 2. So what I'll do is to take this one this side. So I'll have x minus 1 into brackets. I take this other one this side, it will be x plus 2. So this one is easy because it has no fraction. So then now I'll substitute. Now I can write my limit as x approaches 1 into x minus 1, x plus 2 over x minus 1. And then now this can cancel with this one. And then there I'll have, when I take the limit, so I can write this as limit as x approaches 1 into x plus 2. So when I substitute, when I put 1 where there is x, this answer will give me, it's 1 plus 2, which will give me 3. So that is the answer that we are having. So there's an alternative method. Now in the next video, or in the next section, we are going to talk about the Hopital rule, which now we can use also to evaluate limits, but this one is based on differentiation. Okay, it's based on differentiation. So we shall touch a bit to see how we can differentiate, and we shall prove that the answers that we can get on factorization are the ones also that we can obtain in the same as that we can obtain using Hopital rules. So please don't forget to subscribe and share and like and hit the notification button for more videos and notifications. So thank you for watching Mr. Academia, and may you have a nice time. Thank you.